Hi everyone, welcome back. So let's get started with the Python collection. So in this video we are going to learn about two very important Python collection family like a list and a tuples, and in the next video we'll learn about the dictionary and a sets. So let's get started with the list first, and then we'll see about the tuple in a later half of the video. So list is nothing but if you have already experienced in other programming language, it is like an array. So you can consider list is like an array and it has a ordered sequence of element. So let's say if you want to put some element in one particular list, so we can use such a kind of bracket notation. And in a last video and a video before in a Python section only, I have shown you how to create the list. But now with some very formal way, I am going to show you how to create a list inside the Python. So let's say I want to keep 3 elements. So I can just separate out all those elements with comma, and before and after comma I can put the elements. So let's say I want to keep like, let's say 23, I want to keep like 4, or I want to keep like a 67. Let me just execute it. So it has written me a brand new list object which is having a total 3 elements. So first is 23, then 4, and then 67. If I want to find what is the type of this particular list, so I can just simply use the type function and I can pass this list. So it has returned me the list. Okay, let me just remove it for time being. This is just to show you that the kind of object Python has returned us, which is nothing but the list type. Okay, so now we have included just the numbers only, but it is not just limited to the numbers, but you can even include, let's say along with the 23 is just the integer only. You can even include float numbers also, or you can include the boolean also, so like a true, or you can include another complex object. Let's say we can include string also. So I am just writing the string like I am in list. I am a string, I am in a list actually. Okay, let's say you can even include a list within a list. So let's not go list within a list at this moment. So let me include something more. Let's say 12.5, one another float number, and let me just assign it to the variable, let's say lst. And now if I try to find, let's say type of this lst, it will give me the list type object. Okay, so now our list has total 5 different elements, and all are having a different data types. This 3.5 is float and 12.5 is also float. Now let's say if you want to extract some particular element available inside the list, so we can use this bracket notation and indexing notation. So I can just simply write like lst and use like a bracket. Now all those indexing, generally in any data types available in a Python, generally it starts from the 0 wherever this numerical indexing is applied. So indexing number 0 is pointing here to the 23, 1 is pointing to 3.5, then 2 is pointing to true, and 3 is pointing to I am in a list. So I can just simply type like a 4 and it has returned me 12.5 because 4 is pointing to 12.5. If I just do lst, let's say 3, so I get like a I am in a list. So that is pointing to this particular string. Now let's say instead of just one number, if I want to extract multiple elements from this particular list, so I can use the slicing notation. So this slicing notation already we have seen while extracting couple of characters from the string also. So we are going to use the same notation. So lst, then we'll put brackets, and inside the bracket we'll give the start index and colon and then end index. Now here, let's say if we want to extract this true and I am in a list. So true is pointed by the number 2 currently. So I can just put starting from 2, ending 2, 3 I want. So upper bound is always excluded. So I am just going to write like a 4. So now all the element whose indexing are starting from 2 to 4, it will return excluding 4. So let me just execute it. So now it has returned me true and I am in a list. So total 2 element it has returned. So it has just wiped out. Let me just print it again, LST. So you can see 2 is pointing to true, 3 is pointing to I am in a list, and 4 will be excluded. Now if you want to include even 4, you can just simply use like LST 2 to 5. So 4 will be included but 5 will be excluded, even though no element has been pointed by the index number 5 in our case. Okay, and now let's say if you want to grab all the element after the index position 1, so I can just simply use starting position 1 and all the element or all the rest of the element I want to extricate. So I'm not going to provide any index number in end position, and it will return me all those element from this 3.5. So from 3.5 all rest of the element it has written. Now let's say from starting 23 all the element I want till this true, so I can just simply use colon. Now before colon I have to provide the start position. So start position in this case 0. So if you provide it then also it's okay. If you don't provide it, by default it will assume like a 0. And I want till true. So true has been pointed by the number 2. So 2 will be excluded, so I am just going to put it 3. So you can experiment with, and by little practice you will get the idea that how this indexing will work. Now let's see a couple of methods what we can apply on the top of this LST variable, which is nothing but the list object. Okay, apart from that, one more thing, this is all about the positive indexing we have seen. Let's see about the negative indexing. So now 0 points to this 23, 1 is pointing to 3.5. Same way, if you go from other way around, -1 has been pointed by this 12.5, -2 will be pointed by I am in a list. So if you want to, let's say, grab last element, so instead of you can grab with a 2 different ways. So 0, 1, 2, 3 and 4. So if I just write 4, then also you will get it. But suppose if someone says you that independent of if you don't know about the length of the or total number of elements available inside your list, and still you want to grab the last element, so you can just simply use like a -1, and -1 will be pointed by this is pointing to 12.5. So the same way, if you want to grab, let's say I am in a list, so in that case you can just simply use -2. So I am in a list. Okay, so we have seen the slicing notation, positive indexing and a negative indexing. Now let's see a couple of methods what we can apply on the top of this list variable. So let me just print this list variable once more, and let me create some few more cells. Let's say if I want to remove the last element, so I can just simply use the pop method. So it has returned me the 12.5, which is nothing but the last element available inside the list. And if I just try to print it again, now you can see 12.5 has been removed. Now I have just a 4 element available in my list object. Let's say if I want to add some more element in my already created list, so I can just use methods like append, and let me just give like, let's say 6.9, and if I just do the LST, you can see another element has been added. Now instead of just one element, if you want to add, or if you want to merge two lists, I won't say merge, like an append to list, so you can use like append, and instead of just passing one number, you can pass even brand new whole list also. So let's say I want to append like a ABC, 3 elements, and all are string only. Okay, and if I just do the print, now you can see the full new list has been added or appended. Now you may consider this particular list as a full one object only, because this is like a list within a list. Now let's say if you want to remove some element, so you can just simply use like we have used the pop, so last element will be removed. Let's say if you want to remove like 3.5, so I am just going to supply 3.5, and let me just print it again. So now you can see 3.5 has been removed. Okay, let's say if I want to reverse this particular list, so I can just simply use the reverse method, and it will reverse every single element inside the list. So now whatever the last element which will come at the first, and first element will go to the last. So let me just print it. Now you can see ABC is the first element. This full is a first element, so don't misunderstood that this is a 3 element, but as a part of ABC is a part of one another list, so that as a part of this sub list it will be considered as a 3 different element. Let's say if you want to find how many times one particular element occurs, so let's say 23. So I'm just going to use the methods like a count, and if I just supply 23, it will return me 1 because 23 occurs one time only. But let's just add, or let's say append 23 one more time. So if I just print it again, now I have a 23 2 times available, and if I just apply this lst.count method again, now you can see I got the 2. That means 23 occurs 2 times. Apart from that, there is a number of other methods are also you can try it out, like sorting. You can remove, we have done. Insert, I think we have done. Then there is extend, count. Okay, count we have done. You can clear the full array. Now let's say if you want to find how many total number of elements are available inside your list, so you can use like a len function, and you can just simply supply this lst. So there are total 6 elements. So this is the first element, then second, third, fourth, fifth, and there is a 223. That's why it is total 6 elements. Okay, so we have seen about the enough methods and attributes what we can apply on the top of this list object. Now let's move towards the tuples. So I'm just going to give the headings like tuples. Okay, so tuples you can consider is like a exactly list data type only, but non-modifiable. So in a list we have done all those kind of operation like addition of element or removing of element, assigning element you can do, but in tuples is like a immutable. So you once the tuple has been created, you just cannot modify it. And to create the list we have used such a kind of brackets, but to create the tuples we have to use this kind of brackets. So let's say I am going to create with 3 different elements. Let's say ABC, very simple, ABC. Okay, let me just assign this ABC to some tup variable. So I am just going to assign it. Okay, if I want to know what is the type of this tup variable, so it's a tuple type of object, this tup. Same, all those slicing notation will be applied here also. So if I want to grab, let's say the first element, so which will be pointed by the index number 0, so I get A. If I do the same thing with let's say 2, I get a C. Okay, and all those slicing notation also you can apply. But one thing I would like to point out here, that one thing you just cannot apply here. So let's say if you want to modify the second element B to let's say M, so if you just try to do like 1, so 1 is been pointed by B. Now if I just try to assign, let's say with some other character, let's say M, and you can see what will happen now. So now it says that tuple object doesn't support the item assignment. That indicates that you just cannot modify already created this tuple object inside the Python, because it is an immutable. So any operation which tries to modify this particular tuple object, you just cannot perform on the top of this tuple. Apart from that, you can apply all other methods. Let's say what you can apply like a count. So count you can apply, let's say A. So A already occurs just 1 time, so it has returned me 1. Okay, so that is all about the list and the tuples. We have covered many of the methods and attributes what we can apply on the top of it, but still there might be some few might be left. You can just practice around with this tuple and list object, and these two are one of the very important collection type available in Python. So when you go at a very higher level Python study with data analysis and all those kinds of tasks, here somewhere and somehow you will find the uses of this kind of objects. Okay, so that is all about the list and the tuples. In the next video we'll see about the dictionary and sets collection.